section 1.4. So this is where we are now introducing the other types of sampling methods. And remember how we were talking about this last time. You want to make sure that whatever sample you select is a good representative of your population. Alrighty, so talking about stratified sampling here, we're saying this is obtained by separating the population into non-overlapping groups called strata, and then obtaining a simple random sample from each stratum. So that means from each group that you have used to subdivide your population into. The individuals within each stratum should be homogeneous or similar in some way. So basically with stratified sampling, we're talking about breaking up our population into some kind of groups or stratum, as they're calling it, and then picking from each group, each stratum, each of the strata. So here we're talking about an example. The president of DePaul University wants to conduct a survey to determine the community's opinion regarding campus safety. So the president divides the DePaul community into three groups: resident students, non-resident, that is commuting students, and staff members, which also includes faculty. So if there are a total of 6,204 resident students, 13,304 non-resident students, and 2,401 staff, that's a total of 21,909 in the population. He wants to, or they want to, I guess, obtain a sample of 100. They're basically saying, okay, we take the resident students, which is 6,204 divided by our total. That's 28% of the sample. Non-resident students are 61% using the same calculation. And the staff constitutes 11% of the sample. So basically, since we want 100 individuals in the sample, you take each of those percentages and multiply it by that 100. So you can see we did 0.28 for the resident students. So that's 28 resident students. 61% would of course come out to be 61 non-resident students. And then what did we have? 11% for the staff. So that's of course 11 staff members. So that's how you basically come up with the stratified sample. And then you can of course go ahead and approach whatever survey the president wanted to conduct. Now, again, you guys can read the example more in detail on your own time. Our third sampling method, so remember, we talked about simple random sampling on Monday. That was stratified sampling. Now we're looking at systematic samples over here. So this is obtained by selecting every kth individual from the population. The first individual selected represents a random number between 1 and k, and then from there you pick the kth member. So what does that mean? So I do want you to look at this little paragraph here. So this little example here, paragraph. To obtain a systematic sample, select the k number, randomly select the number between 1 and k, and this, you kind of begin from that point. So basically we are saying, let's say we might decide to survey every 8th individual in our population. We randomly select a number between 1 and 8. Let's say that comes out to be 5. So you would start from number 5. You're kind of numbering all of the individuals in your population. You start at number 5, and then every 8th member after that. So that's what becomes your systematic sampling. So for an example, let's look at this one here. The manager of Kroger Food Stores wants to measure the satisfaction of the store's customers, design a sampling technique to obtain the sample of 40 customers. So here they're talking about, I'm looking at the solution. The manager decides to obtain a systematic sampling by surveying every 7th customer. He then randomly selects the number between 1 and 7. Again, they're using 5 here. So the 5th customer who is exiting the store is the first one he talks to, and then every 7th customer after that. And then of course you keep going till you get that sample size of 40 customers so that they can do that. Now, to select your k value, that's kind of what they're going over here. In this case, is we're saying, okay, if the size of the population is unknown, then there is no mathematical way to determine the k. But they're also saying that the K value must be small enough so that you can get your desired sample size. So you want 40 customers, 100 customers, people, whatever. Basically, you would kind of go through, an idea of what my sample size needs to be, and then you can kind of choose that. But if you are given a population size, then it makes it a little bit easier. So again, looking at that bottom paragraph here, so looking back at that Kroger example, if K is too large, let's say 30, that means you would be serving every 30th customer who is exiting the store. So again, you're starting out at 5, and then you're talking to every 30th person after that. And a sample of 40 would that means require 1,175 shoppers to visit Kroger on that day. Not to mention the manager is just standing there waiting for the 30th customer to step out, which in my opinion is a major waste of time. So that 30 as a K value would not be appropriate. If Kroger does not have 1,175 shoppers, then of course you would not even achieve the sample size you wanted for that day. So that again wouldn't be too handy. They're saying on the other side, if K is too small, let's say 4, that means you are serving every 4th customer, then 161 shoppers might exit the store at 3 p.m. And of course, then that means you're not really including the shoppers who may be coming in the evening time. And that may, again, not accurately represent your population. So that's kind of where you have to be careful about when you are choosing that K value. So there is actually a little formula that you can use, but this is, of course, you need to know your population size, and you can see that in the steps over here. So if you have an approximate idea of the population size, remember that's your capital N. We determine what the sample size will be, that's your small letter N. And then you can see you take capital N, that's the population size, divided by small n, which is the sample size, and that gives you your K value. And then you can randomly select a number between 1 and K. They're calling it P, and then basically, you start from the P value, and then you keep adding K to it till you get that sample size that you're looking for. All right, so this was our third system for gathering sample. Now let's talk about cluster sampling. Now, cluster sampling, as you will see again in the definition, we're saying is obtained by selecting all individuals within a randomly selected collection or group of individuals, which is kind of something similar we had done in stratified sampling, because in stratified sampling, we divide our population into strata or groups. But the difference is in stratified sampling, you pick a population from each group, from each strata. In cluster sampling, you pick the entire group. So you're not going to each group and selecting individuals from it. You're saying, okay, I have 5 clusters. I'm going to take 2 of them, and that becomes my sample size. So the other 3 groups, you don't pick anybody from that. So cluster sampling is take the entire group, and that becomes your sample size. Stratified is from each group, you have to select individuals, okay? So the example here we're talking about is a sociologist wants to gather data regarding household income within the city of Boston, and they're using cluster sampling here. So if you look at the solution here, they're saying, okay, suppose there are 10,493 city blocks in Boston. First, the sociologist must pick a number, actually number all the blocks from 1 to 10,493. And then they're talking about if they have enough time and money, they will basically survey 20 clusters, which means 20 city blocks. So you would then, randomly select 20 numbers from 1 to 10,493 and those 20 blocks. But that also means from that block, you are talking to every individual within that block, right? Because that's how cluster sampling works. So they're saying the sociologist should obtain a simple random sample of 20 numbers and then go to all the households within that cluster and pick. Now they're saying cluster sampling is a good choice in this example because it reduces the travel time to households that is likely to occur with both simple random sampling and stratified sampling. In addition, there is no need to obtain a frame of households for the cluster sampling. The only frame needed is the one that provides basically from the city block itself. Because you're just commuting within that block, you're not having to go from block to block while you are in that one city block, you're talking to everybody there. The last one here, guys, we're talking about convenience sampling, and I had mentioned this a little bit last time. Convenience is in which the individuals are easily obtained, and it's not based on randomness, which also creates a lot of problems because your data may not be representative of your population, so there might be a little bias in there, and we'll talk about biases and stuff like that a little bit more. So just some terminology that you should see in that paragraph underneath the definition. We're saying the most popular of the many types of convenience samples is in which the individuals themselves decide to participate. So that would be self-selected. These are also called as voluntary responses. So a classic example would be, if you listen to a podcast or a radio show or whatever, where they have live callers, right? They say, hey, call us and share your opinion. That would be an idea of voluntary response or self-selected. So what happens in that case is if you feel very strongly about the topic that they are talking about, then you're probably going to be the person who calls in. Or if you are on the opposite side of that topic and you feel very strongly against it, then you may also call in and say, this is my opinion. So what happens in that case is you are leaning either too much in favor of that subject or too much against it. There's very rarely somebody who's going to call and say, I kind of see this point of view also, but I also kind of agree on the opposite point of view. So this is kind of where your responses would be very biased. Or think about, I guess people don't really do magazines or newspapers anymore, but let's say if there's a website you frequent for your news or whatever, and if they have a poll on that website, you choose to participate, same thing, right? Maybe you are in favor of that topic or you are entirely against it, and that's why you chose to participate. So again, your responses can be pretty biased depending on, what the question is and how it's being asked. So that would be convenience sampling. And then they're talking about multi-stage, where you can kind of do it, at different stages, you can try different sampling. So you can kind of look at that. And then this one here is just kind of talking about sampling size. And you can again read that, but we'll get a little bit more detailed into it, as you can see in chapter 9, once we get there. Let me make this map a little bit small so you can see. Yeah, okay. So you can see basically simple random sampling, which we talked about on Monday, was you label all the individuals in your population and randomly generate the number using a table or the random.org website that I guys showed you, and you select your sample size. This is stratified sampling over here. So you can see we've actually broken the individuals down. Here it looks like gender-based. And then from each group, you are selecting your sample. In systematic sampling, you can again see we've got all the people labeled, and then using your Kate value, you select your population. So they're saying, okay, what if we start with the second person, and then you are doing every third person in your population. So they got the second person down, then the fifth person, that's 2 plus 5 is 3, plus 5, 5 plus 3 is 8, 8 plus 3 is 11, so on and so forth, right? And then you can see in cluster sampling, we've taken the first 12 people, created a group out of that. We've taken the last 12 people, created a group out of that. And then we've actually broken them into 3 separate groups, or a total of 6 groups, right, for the entire population. So you will see here, we take the entire cluster, which means looks like they're selecting group 1, which is people 1, 2, 3, and 4. And then they're selecting group 5, which is 17, 18, 19, 20. But we have nobody from group 2, nobody from group 3, group 4, or group 6, right? Those groups were left completely out. Stratified, you take samples from each of your groups, okay? So that's the difference between cluster and stratified sampling. So what I want you guys to do is to apply these techniques. And these are just random things that I have received from Ames. Whenever we go to like conferences and whatnot, this is going to be your population. What I want you to do is just take a handful, that's gonna become your population. And then we'll talk about sampling. Ooh, that was a big handful, nice one. Do one more than that. Do it one more, you have tiny. Not a bad thing, I didn't mean it as a bad thing. Like I said, this is just stuff I have received from the conference, so I've just thrown them in there. All right, so what I want you to do first, and you may want to move your tablets out of the way so you have space to work at, arrange this in a grid. So like, you know, a table, 4x4, whatever you can do it, arrange it in a grid. Cameron, do you need more people in your population? You think you're okay? Yeah. I blame Aaron. He took a big chunk.
Oh, yeah.
That's okay. Alrighty, so make a note of what is your population size. So Cameron, what's your population size? Aaron, who do we have next? Omar?
13.
13. Christopher? What? And Bibby?
10.
10. Okay. This is your population. Alrighty, so you wanna select, I think almost, Christopher, you're kind of on the lower end, but, let's say a population size of 5, okay? Sorry, sample size of 5, not population, sample size of 5. Let's start with random sampling. So how are you going to select 5 individuals from your population using random sampling? So you can use random.org. So random.org, if you are doing, you would be doing, like Cameron, you would be going 1 through 10. Aaron, you would be doing 1 through 14. Of course, Omar, 1 through 13. Christopher, 1 through 9. Libni, 1 through 10. So again, you guys can use random.org. And to save time, instead of using the little random number generator here, I would say scroll down and go to the integer generator. You will see it's under the numbers category. And then you can say, okay, I want to generate 5 numbers. So change that to a 5, and then you can go from 1 to, like I said, whatever is your maximum. I'm going to do Aaron since he's got the largest number, 1 through 14. And you can say, okay, give me 5 random numbers, right? And you can get your random numbers that way. So then you separate, you know, again, number your grid how you want to, and then you can get your population from that. So go ahead, separate your population, and let's see what you come up with. Can you move your laptop to that side so that way I can see your population better? Thank you. So Cameron, I see you already got your population, sorry, your sample. Do you think it represents your population well, or do you think it's leaning towards some type of individuals more? You little guys, okay? Because you had the slinky, you had the little swish, whatever it's called. Simple. But you have two of these astronauts.
5.
But then you still did pretty good with the other items. How are we looking
Yeah.
here? Looks like you've got more of the stress ball so far. Ooh, this one. Which looks like your population has a little bit more of the bubbles in this. Where's your sample? Not bad, I think it's pretty well mixed. What are we looking at as your sample? So you're definitely biased, but it looks like you have more of the bubble, what is it called, bubble pops? Where's your sample?
Confused,
Okay. So what you are doing is go to the. Did
Yeah.
you say 1 through 10?
no, I said,
Okay, go ahead and set up your grid.
this is my grid,
Okay, where are you starting your count as? Where's number 1?
here, 1,
Where's 2? Okay, so you have, I can't see, sorry, I'm blind. I'm blind. So you've got 4. So if you're starting 1, 2, where's number 4? Let's set them out. 6, so that was 4. Where's your 5? No, that was 3. Can you count here? 1, 2, 3, 4. Yeah, but that's not how you set up the grid. Go back to your grid. You'll get your 5 point. Put 5 is here, put 5 is here.
I like this.
Okay, so that is 5. Where's your 6? Don't forget, the guy was here. It means 4. He's gone. If you're, are you starting 5 from here?
This one?
Okay, then we will go for the next candidate. You cannot do 4 with 8. Okay, so you need 2 more numbers. So go back and generate 2 more numbers.
Okay.
Okay, so you felt like you had too many of the astronaut guys, right? This was random. Two astronauts. What did you have? 3 of the squishy
Yep.
stress balls? You had 2 of, what are those called? Bubble pop? Bubble wrap? It's supposed to be the idea of a bubble wrap popper thingy. I don't know, I'm gonna call it bubble wrap. You had 4 of those, didn't you, Christopher? 4 of the bubble. And with me, what did you have? You also had 2 of the bubbles? But then, Bunsen, one, whatever that little plastic thingy is, and whatever it's called, sorry. What is it called? Mini bubbles?
Yeah.
Yeah, okay. All right, now go back and mix everything well and rearrange it in a grid. So mix everything so that way we're not picking the same items again. And this time you are doing stratified sampling, which is where you need to break it up into strata based on something similar. Stratified. So how can you break them up into groups? And you can choose how many groups you want. You want 2 groups, you want more than that. But remember, they have to share a similar characteristic, right? So they have to be same in some way. So what would you choose, Cameron, as your grouping? How would you group your population?
Yellow on.
Okay, so you're doing by color, so you have yellow. And what's your other group?
Yellow.
These 5 things have white on it.
White. Okay, Aaron, what's your grouping?
All of these in one group?
The bubbles?
Yeah.
Okay,
7. And all of the rest.
okay, and non-bubble? Okay. Omar, what's your grouping? Bubbles,
Yellow.
yellow,
And random, I guess.
Miscellaneous? Okay, what's your grouping?
I have a group of two box thingies over here and then slinky.
But what's the commonality between each of your groups?
Two s- Like I am.
So if you're doing square, why are not these two with the square stuff?
Well, because there's two over here and then there's two over here.
No,
I have to be together.
because remember the idea of a group is they have to have similar characteristics. So if you're using square, then all square things should go together. Okay, so we're doing square. What's the middle group?
Random stuff.
Random. Something.
Slinkies.
Okay, so you are doing square, miscellaneous, and slinky. Libni, what grouping are you doing?
Doing round,
Round,
square, and just
Square.
whatever.
miscellaneous? Okay, so, Cameron, you have two groups. What sample size do you want to choose? Obviously, it's gotta be, smaller than 10.
6.
Okay, so are you gonna do? Well, I guess the idea is what's your percentage for each group? So how many do you have in the yellow? 4, so 4 out of 10 would be 40%, right? Okay. That means you would have 6 in the white group, right? Okay, how many do you have in your bubble group, Aaron?
7.
7, so that would be 7 out of 14, which is 50%, right? Which means you would also have 50% in your non-bubble, right? 7. Okay, how many did you have in your bubble? 4, so that's 4 out of 13. What's 4 out of 13? You've got a laptop, go ahead, calculate. Probably not a happy number.
3.25.
3.25?
Yeah. Oh, like, wait.
It gotta be 4 divided by 13.
Oh, yeah. 30.76.
Okay, how many did you have in your yellow? You're gonna need that cell phone still. 4?
Yeah, it's just,
It's the same thing, 30.76. Which is what, 8, so that leaves you with 5 in the other last group.
38.46.
38.46. All right, not happy numbers, but we can work with that. How many in your square? So again, guys, it's 4 divided by the population,
0.4.
so 44%. How many in your miscellaneous? Is that 3?
0.3.
Yeah, that's 33% repeating. And then you had what, 3, 2 in the other one?
2.
So what's that percentage? 2 out of 9.
22.
Okay, Libni, how many in your round?
3,
So that's 30%.
4,
In your square, 40%,
and 3.
30%. All right, so you said 6 was your sample size. So of course, you're doing 6 times 4 out of yellow, 6 times 6 out of your white. If it's use the regular rounding rules, guys. So if it's 0.5 or more, go up. If it's 0.5, less than 0.5, which is 0.4 or less, then go one number down. So 6 times 4 will give us what? Which means 2.4, right? So I would say pick 2 from your yellow. And you can do the same thing like we did for simple random sampling, put a number 1 through 4, and then whatever 2 numbers generate, use those. 6 times 6 is 36, which means I would say go up to 4 to pick your white. Okay, so that means you would be doing yellow. What did we say, 2? And white would be 4, so that gives you a sample size of 6. What sample size, Aaron, do you want to do?
Bubble.
No, total sample size out of 14. How many did you want to pick in your sample? 5? Okay, so 5 would be not possible because you have 50%, right? So half of 5 would be 2.5, which means then you would have to pick 3 from your bubble, and you would have to pick 3, well, let's call this non-bubble. So it would actually bump you up, right? Because just because the way your numbers came out to be, because if you did 50% of 5, that'll give you only 2.5. So you have to round up the 2.5 to get to a 3. So I would say it may be easier just with the numbers you had to change your sample size to 6. Okay. Omar, what sample size do you want to pick out of the 13 you have? I mean, your numbers are kind of funky, so we may have to play around, but just randomly give me a number. 6?
Yeah,
Okay, what is 6 times 30.76? Hey, that's why you have calculators. Trust me, if you had to do this by hand, we'd be here till midnight.
6 times 30, 184.56.
Well, did you convert your 30 into a decimal? So it should be, remember, 0.3076 multiplied by 6.
1.8456.
Okay, so let's pick 2 from your bubble, 2 from your yellow, and now do 6 times 38.4 or 0.3846.
2.30.
Okay, so actually it would just come out to be 2 each for you, okay? All right, Christopher, sample size. You've got 9. 5?
Yeah.
Let's try 5 and see what happens, because again, you don't have very happy numbers either.
Yeah.
What is 5 times 0.44? Mhm. Okay, so let's do 2 from your square. For your miscellaneous, it's 33. So same thing, 5 times 0.33. So that brings you at 2 also, and then 0.22 times 5. This was your square, this is linking. So 1. Yeah, so you can get 5 out of that. Libni, sample size. You've got 10 total. You wanna do 5 also? 6.
6.
Okay, we'll try. What's 6 times
I have
0.5?
5 actually.
Okay, 5 times 0.30 for your round.
30. 1.5.
So 2. Square 0.4 multiplied by 5.
0.4.
Yeah, because you had 40%.
2.
2. Okay, miscellaneous 0.3.
1.5.
Okay, but since your sample size was 5, you can only pick 1. Okay, so same exact thing, guys. Now that you have how many you need to pick from each group, you will do the same thing. So like Libni, for yours, you would label all of your round as 1, 2, 3, 4, how many ever you have, and then randomly select 2 numbers so that you can get 2 from your round set. Christopher, you had 2 in your miscellaneous, so how many ever you had in your miscellaneous, put that in your random number generator and select 2 numbers out of that, because as much randomness as you can do should be more better at representing a population, right? Because we're not saying, oh, you look pretty, so I'm gonna pick you, or oh, you look like I can use you more, so I'm gonna pick you, because that's where bias happens. So that's where you need to do a random number generator. So tell me what your sample size is. I mean, your sample looks like. So you had total of 6. Where's your sample?
These were the two that got separated out.
From the yellow?
This was from the yellow group, this one was.
So
from the
that's your
white.
slinky and a stress ball, and then looks like from the white, you had 2 astronauts, 1 bubble blowing thingy and a bubble popper thingy. That's actually not bad. I mean, you do have kind of more astronauts, so it's not surprising that you picked 2 astronauts again. Aaron, you had 3 from your bubble, so those are the 3. And then those are the non-bubble, which is a stamp. Is that like a spider top that you can
It's a-
spin?
Spent out.
And then 1 stress ball. That's actually pretty good because you're kind of leaning heavy on your bubble popper thingy also. So that's not too bad. Okay, Omar, you had 2 of your bubble. Where's your sample?
Oops.
If only I could hang him upside down. Christopher, let's see, you had 2 squares. Where's your sample, buddy? You can't do that. You need to do it randomly. Let's generate those numbers and get our samples there. Libni, you have 2 round. So what was your other round object?
This thing,
Okay, yeah, I'm not sure what that is. Okay, so you got 2 stress balls. You had 2 from your square. What's your other squares at? Okay, so those guys got left behind, and you had 1 miscellaneous, which you picked a metal slinky.
Yeah.
Okay. You have the most diverse sample at this point. But that's also because your population just has more squares in it. Yeah. Yeah. Yep. All right, while Omar and Christopher are catching up from slumber,
Somewhere down.
where's your sample? All right, why don't you guys go ahead and we'll be doing systematic next, so mix up your product again, all of it. So that way we can now calculate our cake value and then do the systematic sampling. So just mix them up. Yeah, yeah, you're good. We're just waiting on Omar and Christopher to finish samples for.
But generally,
Okay, now you will need to put this in a grid.
I thought I did it right.
Okay, so you had Omar, 2 from your bubble popper thingies, okay? And those 2 got left behind. Okay, then you had 2 of your yellows. You got a stress ball and a bubble blowing thingy, and you had what? Omar, miscellaneous 2. What's your miscellaneous? Got a little puzzle, okay, maze kind of thingy. Okay, good. Are you done?
2.
So 2 squares. 2 miscellaneous is your stress ball and whatever that spin top thingy is. And then you had slinky as your 3rd group, so you picked 1 slinky. Okay, mix them up really well. And then put it in a grid, so you can do 2 by 3, 4 by 6, you know, whatever your population size is. Okay, so remember, when we are talking about selecting our eval. There we go. Okay, so you each know your population size. Let's keep our sample at 5 for all of you, because I think going too high may again run into where we may not be able to get enough. Can we get enough? 5. Okay, pick a random number between 1 and 2 on random.org. Just between 1 and 2, because your population is not big enough to do between 1 and 5. So just let random.org help you decide a number between 1 and 2. Do you have a starting point? Okay. All right, guys, so now your sample size is 5. So this is for systematic. To calculate your K value, you are going to do capital N divided by small n. Which will give you 10 divided by 5 for those of you who have 10. So that should give you a 2, right? So that means you will be picking every second number. For those of you who have like 14 divided by 5 will give you what? Who had 14? Aaron, what did 14 divided by 5 give you? So that we can calculate our K value. So for the K value, Cameron, you would have 2, and Libni, you would have 2. What's 14 divided by 5? 3.8? 2.8, so let's round that up to a 3. Omar, 13 divided by 5?
2.6.
2.6, so we'll need to bump you up to 3 also. Christopher, 9 divided by 5? So we'll need to bump you up to 2 as well. All right, so now the number that you picked between 1 and 2, you got a 2. Aaron, what did you have? 2, 2, 2, 2. Okay, so each of you in your grid are starting from the second place. So which is your second object? Pick that, that's your sample. Separated, okay. Now, Cameron, you're gonna pick every second item after that till you get a total of 5 in your sample. Aaron, you are picking every third one after your starting point. And keep going till you get 5. You are doing, Omar, also every third one, so you pick the second, do the third one after that. Christopher, you're doing every second one after that. And Livni, you are also doing every second one. So make sure you keep going till you have a total of 5 in your sample. So go back from the start and recount.
I did 2, 3, 1, 2, 3, 1, 2, 3, 1, 2.
So go back to the start now.
2.
Okay. Show me your count again. You started from the second one. Then you did 1, 2, 3. Okay, then 1, 2, 3. Okay, then 1, 2, 3. So that becomes 1. The last square,
This one?
the last square, 1. Then your star becomes 2 at the beginning, yeah. Because you're just going in a circle, right? So that blue white square is count 1. Star is count 2. So the skateboard will now become your count 3. And that you can take and put into your sample. So that way you can have a total of 5. So does everybody have their 5 samples? Where was your count 1 at? Where did you start counting?
1, 2. Count what?
Like, what was your original grid like? And you can just randomly set it back into a grid. Okay, so you had, your starting point was 2. That's what you told me.
Oh, yeah.
Start from the second one, pick it. That's your sample. Get it out of the grid. Then your, Christopher, you were doing every second after that. So now you count 2 units from there. Okay. 1. So come back to the start. There you go, 5. How many do you have? Do you have all 5?
Yeah.
Do you guys here have all 5? Okay, so would you say, does your sample represent your data pretty well, Cameron? And we're kind of seeing the same trend, right? You're getting more astronauts and other objects, but I'm still seeing a maze, the little bubble thing, lately, so that's pretty good. You are, of course, heavy on your bubble square, so you got 2 of those, but 1 top, 1 stamp, 1 thingy, stress ball. What's your sample?
There's
I'm not seeing what's behind the plastic bag. Okay, so you got one maze, one square, one skateboard. One whatever that little ball is. Now, is the bubble blowing thing part of your, or is it the one in your hand? Okay, so you got the little fidgety thingy. You have that maze, you've got two slinkies and two squares?
Correct.
Okay, so you are a little,
Two.
so it looks like you're kind of leaning towards two similar items in your sample. You've got two of the stress balls,
Oh, just one.
just one stress ball, one slinky, one bubble blower, and two squares?
Yeah.
That's not too bad. Alrighty, our next one is cluster. Cluster can be just any groups. So you decide how many groups you want to break up your population into. However you want to group them. Do it on color, you can do it on size, you can do it on shade, whatever, and how many ever clusters you want. So remember, in cluster sampling, you pick all the members from that group. You don't go into each group. So thinking about that, you want to think about how I want to create my groups. Okay, does everybody have their groups? How many total groups do you have? You don't yet? Are you still kind of thinking how you want to group them? Yeah? Okay, so let me create some space here. We are doing. Yes. There. Okay, Aaron, do you have your clusters or you're kind of still working through them?
I got them.
Okay, how many total clusters do you have? Seven, okay, wow. Omar, do you have your grouping? How many total groups, clusters? Three? Christopher, three? Do you have your groups? Three? Four? Okay. So those of you who are not Aaron, you probably want to pick two clusters. So number your clusters, 1, 2, 3, 4, you know, whatever, and then randomly choose two numbers out of them. Since you are at 7, I would say you could do 3 or 4. I'll let you choose. How many clusters do you want to pick?
3.
3? Okay, so you are choosing 3, and the rest of you are choosing. So basically what you would do is you would then generate a number between 1 and 4 twice, right? So you pick two numbers between 1 and 4. You're going to pick 3 numbers between 1 and 7. And then all 3 of you are going to pick 2 numbers between 1 and 3. So again, same thing, go to random.org. Say I want to pick 2 numbers from 1 and 3. Honestly, those of you who have 3, you could technically even probably just pick them. Probably would not give you the best result of seeing at the population.
So generate 2 numbers?
2 numbers between 1 and 3. What numbers did you come up with? So what was your cluster 1? Blue?
And 3.
Okay, so then you got 2 blue items, which is a bubble blower. Is that what you say? Is that what that is? And then you got your 3 astronauts. Okay, so that's your sample. What numbers did you come up with? For you? 6, 1, 3? So which was your 6?
6, 1, and then 3.
Okay, separate those out. So get your 6, 1, and 3. So it looks like you've got 2 stress balls, 3 bubble squares, and 1 fidgety thing, right?
Yep.
Okay, that's your sample. Omar, what numbers did you have between 1 and 3?
2,
So which is your 2 and 3 group? Cluster.
2, 3.
Okay, so that means you got 4 squares one bubble blower, one fidgety, whatever that little jumping dog is. A maze and a skateboard. What numbers did you have?
I have 2 and 2,
Okay, so regenerate it, because obviously that would.
2 and 3.
All right, so which is your group two and group three?
2.
Okay, so that means you would have three bubble squares, one slinky, one whatever top, and then that puzzle. What numbers did you come up with?
2 and 1.
So which are your two and one groups? Okay, so you've got three squares, well, actually, three stress balls and another ball. So no slinkies, no lower thing. All right, let's mix up our population. So this one seems to be a little bit more biased, right? Because of the way you guys did your grouping. So like you only had all astronauts and then none of the slinkies came through. So, you know, that kind of got left behind.
Little.
Yeah, and that's again because your population does lean towards the squares a little bit more, but I can see the stamp at the top did not make it through. You had no stress things show up in your sample. Honestly, I think Christopher, you probably did better than your classmates just because the way you grouped them. Yeah, your population is kind of also leaning towards one single thing. The slinkies didn't make it, but everything else did. Okay, so I think actually Christopher had the most diverse sample. So you can kind of see how grouping makes a difference, right? You kind of have to think about how I'm gonna group. All right, let's shuffle everything together. Let's mix them up really well. Now, your next is convenient sampling. Each of you pick 5 items from your sample. I don't care how you do it. All right, what do we have? One astronaut, one slinky, one maze puzzle, one square, one bubble blower. Okay, you picked all 5 bubble squares. Is that your population?
Yeah.
Okay, so one skateboard, one stress ball, one square, one fidgety, one jumping frog. 2 slinkies. Is that 5?
No, this is fine.
Oh, that's your sample.
Yeah.
Okay, 4 squares and 1 rectangle.
Yep.
1 slinky, 2 squares, 1 bubble balloon, and 1 stress ball. See, there you go. Actually, you guys are pretty good on your convenience. Did we intentionally try and be more diverse in our convenience sampling? Or was it like whatever my hand could grab? What was the idea here? You were kind of trying not to look at your population, right, and grab. So were you going by feel or just whatever came in your hand? Okay. You intentionally picked?
Community budget was most of.
Okay, so you went with the squares, which obviously we can see. What did you do to pick your convenience? Okay, so best. Christopher, what did you choose?
The squares.
The squares, okay. What was your intention?
Just whatever.
Just whatever?
Yeah.
So was it like whatever was closest to you or whatever looked nice?
Yeah, whatever looked nice.
Okay, okay, all right, that's convenience sampling. All right, very good, guys. Okay, so that was. Lose my samples or population, I guess.
They rolled away from me. They don't want to be with me.
They didn't want to be with you anymore, it's like, I'm done.
Yeah.
You had too much of mixing and prodding and
Nice.
selecting. All right, guys, here's the last part that we want to talk about is what kind of biases can we see in each of the sampling techniques. So basically what we are saying is if the result of the sample does not represent your population, that is when we talk about the sample having a bias. So your 3 main types of bias can be sampling bias, which means there's an error in the way we sampled it. There can be non-response bias or response bias. So let's talk about sampling bias here. Basically, we are saying it means that the technique used to obtain the samples individuals tends to favor one part of your population over another. So like in Cameron's case, I would say you were getting more and more astronauts in the first couple methods that we did. You were getting more squares. I think, Libni, you were also getting more squares in most of your, population. I think same thing for Christopher, because, you had more squares in your population too. So that's kind of where you would be leaning more towards one type than the other. Convenience sampling also has bias because individuals are not chosen through a random sample. Now, this can also result in undercoverage because, if you are only focusing on one part of the population, that means that the other parts are getting left behind and they are not as prominent in your sample, which is where the undercoverage would come from. So that would be obviously a concern going forward. And then you can kind of see some of the examples they have mentioned in here, because what happens is if you have a bias in your sample, then the results you get from your survey or data, whatever you're gathering, will obviously not be correct, which means any predictions we make based on those results would be inaccurate. When we talk about non-response bias, we're saying it exists when individuals selected selected to be in the sample do not respond to the survey, have different opinions from those who do. So they're saying this can occur because individuals selected for the sample do not wish to respond, or the interviewer was unable to contact them. And this happens a lot if you think about it. When my mom was going through her cancer treatment, we went to several different clinics and hospitals, to see doctors and stuff. So they'd send a survey back to us like, hey, how was our service? Blah, 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 blah. The only time I would respond is if I felt like they had not treated her well, or there was something lacking, or they hadn't been as attentive to her as they should have been. But if everything went well, if they did everything like they were supposed to, I did usually respond to the surveys, because my idea was they need to know this is where they were lacking and this is where they need to fix. I'll tell you one example. This was the hospital in Brighton, and my mom had gone in for, I don't even remember anymore now. But the individual who was taking her blood was trying to get, this needle into my mom's arm, and she had very tiny veins. Like, this is something that is genetically present in our family. My grandmother was the same way. I'm not even kidding. They poked her 1, 2, 3. And I think they went up around 4 different places before they found a vein that could work. And I still have pictures of that arm. It's completely bruised and bloody. And I was like, why? She is already dealing with cancer. Why is she having to do this? And then later on, they bring this little scanner. They're like, oh, we can use a scanner to find where her veins are. And I was like, so 4 times you've poked her and now you're going to bring the scanner out. I was so upset. I was so livid when that happened. So I did respond to that survey and I was like, what the hell are you doing? This patient is already going through a hard time. And this is what you're doing, right? So this makes me a biased candidate because I only responded because I was really upset with them, right? If I was going to be responding, then I should respond to all the surveys I received, but that's not a case, right? Think about how many times in the mail we receive surveys and we don't respond to them. And I'm just like, dude, I barely have time to live. I do not have time to fill out your survey, right? So people who will fill it in, like kind of I was talking about calling into a radio show or responding to a poll online, if we're feeling very in one direction or the other, that's when we respond. So non-response bias can be, because people who have different opinions just chose not to respond. So you're only getting answers from one point of view, but not multiple point of view. So that would be a non-response bias. Ames is pretty good about not sending too many of those surveys out, but I'm sure US students are also receiving surveys every now and then. That does not mean necessarily every student is replying back to those surveys, right? And so again, that can be the same thing that can happen is you're not getting enough of the students to reply, which means you don't have accurate information. Response bias, on the other end, will exist when answers on a survey do not reflect the true feelings of the respondent. And this can happen in a number of ways. So interviewer error. A trained interviewer is essential to obtain accurate information. So, if it's a skilled interviewer, they can get responses from the individuals and make the interviewee feel comfortable to give, truthful answers. So they're basically saying if there's a question like, have you ever cheated on your taxes? We think about that question. Many people may not feel comfortable answering that, right? Especially if maybe they have not been truthful on their taxes, they may probably not answer that question conveniently. What other questions do you think might be there where people may not give truthful answers?
The recent election.
Very good. So in what sense, like who you voted for kind of thing?
Yeah.
Okay, okay, I can see that because you don't know how the other person might react to your choice. Very good. What other type of question might not get a truthful answer?
Read.
Okay. Unfortunately for you guys, I can go in my math lab and see when you have not done your homework, so you cannot lie to me on that. You can lie to me if you've read the textbook or not, so yeah, definitely. What else? What other question people may not want to be completely truthful on?
When was the last time you changed the oil?
Would people lie about that?
Like, maybe
I can say could.
maybe you changed it.
Okay, okay. What else? So I'll give you an example from my family. We're Asians, we're short people. We're never going to be tall. If somebody reaches 6 feet in our family, we're like, oh my God, you are tall. Like, you're like up there in the sky. Because, 5'2" is like the average height, especially for women in India. So I have cousins who are barely 5. But you ask them their height and they'll tell you, oh, I'm 5'1", I'm almost 5'2". Like every time I go for my annual checkup, they keep making me short. I started at 5'3", I'm at 5'2.5", but I will fight these guys. I'm like, put me down as 5'3". I have always been 5'3", I am not 5'2.5". But people ask me, I tell them I'm 5'3", I'm not telling them I'm 5'2.5". Shoot, round up, right? So that's a very common thing in my family. If you ask the women their height, they're gonna give you an inch or two taller than what they really are. Right? Think about something else, I had used the example, how many times in a week do you go to a gym? That's something people will lie about. Ask them about weight, people will lie about, right? Because they don't wanna be truthful about some of these sensitive things, right? Like you mentioned politics. That can be one place where people probably don't think it's okay to be 100% truthful, right? So many situations where you may not be truthful, which means now your data is biased, right? Because people were not honest in their responses. The other option here is misrepresented answers. So they're saying some survey question results and responses that misrepresent facts or are flat out lies. So the example they're using here is a survey of recent college graduates may find that self-reported salaries are inflated. Also, people may overestimate their abilities, and kind of that's what I was talking about. Ask people how many push-ups they can do in 1 minute, and you may not get an accurate answer from that. Now, here's the other one, guys. Wording of questions can actually, so if we are the ones creating the survey, right? We're the ones trying to create a survey. Maybe we want the response to go one way or the other way, depending on whatever point we're trying to prove. So wording the question can actually have like a subtext where you are already creating a bias with the way you've worded. So here we can talk about, like you can see, do you oppose the reduction of estate taxes? Versus, do you favor or oppose the reduction of estate taxes? So where do you see the bias in that first question, where it says, do you oppose the reduction of estate taxes?
Also, like if you say yes, it kind of looks like you look bad or something.
Could be, depending on where you stand on that, because the other one is saying, are you in favor or are you opposed? to the reduction, but the first one is just saying, are you opposed to this? So maybe if you are in favor of reducing those estate taxes, you may feel like, oh, but should I say that? Because this is only asking me about the opposition and not about being in favor. Whereas the second question gives you the option to say, yes, I'm in favor, or no, I oppose this reduction, right? So it gives you that balanced option, whereas the first one does not. Here's another one. Do you think the United States should forbid public speeches against democracy? The second one is, do you think the United States should allow public speeches against democracy? And you can see they're saying that those who were presented with question A in this example, 21.4% gave yes, it should be forbidden. Those who were given question B said 47.8% gave no responses. So basically you've changed what, one word in those two questions between A and B, and basically you can see they're saying the conclusion you may arrive at is most people are not willing to forbid something, but more people are willing not to allow something. And just by based on the survey question, you're actually getting two differing data values. And that can really make a difference on how you word your questions. All right, and then they're talking about how even the ordering of questions can make a difference. So if you word them or order them in different ways, can also create a bias. And type of questions, is it an open question or a closed question? So you can see here we're saying, what is the most important problem facing America's youth today? It's open, right? There can be anything that comes to mind. The other one is saying, what is the most important problem facing America's youth today? Same question, but then they're listing 5 options there, right? Drugs, violence, single parent homes, promiscuity, peer pressure. So now in closed questions, again, how you order those 5 options can make a difference. And kind of leaving other things out may also create a bias, right? Because now you have said, these are the only 5 things we're focusing on. Anything outside of that is not of consequence. So that can make a difference. And then, something as basic as data entry error, just the person who was writing the information down incorrectly, put it down. Okay, so you can kind of see some of these errors mentioned over here, guys. Non-sampling errors can come from undercoverage, non-response bias, response bias, or data entry. Sampling errors can come from basically your sample does not represent your population correctly, right? So that's going to be the last part of what kind of bias can be there. I have a little handout that we'll look at for next class, but basically we are done with chapter 1. So again, remember guys, you have 1 week to finish chapter 1 homework. I'll go ahead and put the deadlines in my stat lab. So do not miss that deadline. Okay, and if you need any help, let me know. But enjoy the rest of your week. Have a great weekend, guys. Be safe, and I will see you on Monday, whatever that date is. We'll be in February. All right, guys, take care. Be careful.